Hello everyone, in this video we will solve two more problems on geometry of complex number, that is based on argument of complex number. See, we have seen the two locus regarding the argument of complex number. The argument of z is theta, that means it represents a ray originating from origin, correct? And making angle theta with the positive direction of x-axis and measure anti-clockwise. If suppose that I am having argument of z minus z1 equal to theta, means this ray is originating. A ray is originating from z1, making angle theta with the positive direction of x-axis, okay, and measured anti-clockwise. So this is the one locus, and second one is very important. See, this is z, z1 and z2. So if I rotate this, this is your vector, initial vector, and this is your final vector, correct? So this angle is theta given by argument of final vector. Final vector is z minus z2 divided by initial vector. Z2 minus z, you can say z2 minus z and z1 minus z, that is equal to theta. That concept regarding the argument of complex number we know that, and we also know that the argument of a real number is either 0 or pi. Argument of imaginary number is pi by 2 or minus pi by 2. Argument is not a one function, it is a many valued function, okay? And the principal value always lying between minus pi to pi, including pi. All those things we know about the argument. Argument follows the logarithmic rules, okay? Properties of argument is following the logarithmic rules. We all know all those things. Now here comes the question. Now you will get multiple locus in a single question. For example, here find the area bounded by argument of z. Find the area bounded by argument of z equal to pi by 3. Argument of z is 2 pi by 3, and argument of z minus 2 root 3 into iota is equal to 5. So we are giving how many locus? 3 locus, and each locus represent a ray, because this argument of z equal to pi by 3 represent a ray, correct, which is originating from origin, and as the argument is pi by 3, therefore it is lying in the first quadrant, okay? This is a ray, but this 0 is not included over here, so this angle is pi by 3. And now coming to the second locus. The second locus is argument of z equal to 2 pi by 3 is again a ray which is originating from 0, but as the argument is 2 pi by 3, therefore this ray will lie on second quadrant. That is finished. This is another locus. Okay, fine. Now coming to the third locus, this can be written as argument of z minus of 2 plus 2 root 3 iota, that is equal to pi. So therefore it is originating. This ray is originating from 2 comma 2 root 3. So 2 comma 2 root 3 is the first quadrant complex number. Now the first quadrant is this much, where exactly the 2 comma 2 root 3 will lie. Now look at here. If this is a complex number, so argument of 2 comma 2 root 3 lying in the first quadrant, it is given by tan inverse of 2 root 3 by 2, that is equal to tan inverse of root 3, and that is equal to pi by 3. And argument of this ray is pi by 3, therefore this 2 comma 2 root 3 will lie on this ray. So suppose this is your 2 comma 2 root 3. So this 2 comma 2 root 3 will lie on this ray, because the argument of 2 comma 2 root 3. So many times we are applying the concept of argument in the same question. So this 2 comma 2 root 3 definitely lie on this ray, because the argument of this ray is pi by 3. Whether the complex number is lying over here, all the complex number will have the argument pi by 3, and therefore 2 comma 2 root 3 lie over here. Now from here we have to originate a ray, okay, and that ray must make angle pi with the positive direction of x-axis. Pi means, okay, this is originating from here, correct? This is the ray. This ray makes the angle pi, okay, with the means x-axis, okay. So this is something like that, okay, pi. Fine. Now we can say that, because you know that any real number which is means having the argument either 0 or pi, correct? Either 0 or pi, correct? So here this is the ray. So therefore now we have to find out the area of this triangle. Mind it, whenever argument of z that represent a ray but the originating point is not there, okay, that you don't have to take care over here. This is simply a triangle formed by these three locus, these three ray. We have to find out the area. This is 60 degree, this is 120 degree. So therefore by symmetry you can say that this is minus 2 comma 2 root 3, correct? Now if you are having some doubts that this is 2 comma 2 root 3, that is okay, but this is how you can say that this is minus 2 comma 2 root 3. I am saying about the by the concept of symmetry. This is 60 degrees, this is 120 degree. But if you are having doubt, so you can verify this point is lying on this locus as well as in this locus, and minus 2 comma 2 root 3 ka argument of minus 2 comma 2 root 3 is pi minus alpha, that is pi minus tan inverse of alpha is something like that first quadrant. You can say this is 2 root 3 by 2, that is pi minus tan inverse of root 3, that is pi minus pi by 3, definitely 2 pi by 3. So this satisfied. Now let us see this satisfied this argument, this locus as well. Now z is minus 2 comma 2 root 3, minus 2 plus 2 root 3 iota. This is again minus 2, this is minus 2 root 3 iota. So imaginary part will get cancelled out. We are having only minus 4. So argument of minus 4 is pi. Yes, correct. Because every real number has the argument either 0 or pi. And this real number is a negative real number. Therefore, this argument is pi. So therefore, this satisfied that this point must be minus 2 and 2 comma root 3. And therefore, now area. Area is half into base into height. Correct? Half. Base is this much. This is 2. This is 2, 4. And height is y coordinate of this point. This is 2 comma root 3. Final answer is 4 comma root 3. You understand this problem now very easily. Now look at the second question. Now coming to this second question. What is this second question? Let a complex number w be 1 minus root 3 iota, and let another complex number z be such that modulus of z into w equal to 1, and argument of z minus argument of w equal to pi by 2. So there are three things we are given. Number one is this one. What is this? W equal to 1 minus root 3 iota. What we can do? We can find out its modulus. 1 plus 3, that is equal to 2. And it is lying in, W is 1 comma minus root 3, that is in fourth quadrant. Fourth quadrant. So therefore its argument is minus of tan inverse of root 3, that is minus of pi by 3. So these three things we can easily observe from this given condition. Second condition is given as a modulus of z into w equal to 1, that is modulus of z into modulus of w. Therefore modulus of z equal to 1 upon modulus of w, 1 upon 2. So modulus of z also we have calculated, modulus of w we have calculated. Now the third one is very interesting. That is super important, that you have to interpret properly. What is that? The third condition is argument of z minus argument of w equal to pi by 2. This is super important. So I am telling you that argument of z minus argument of w So just try to understand it in a deeper way. Just I am removing this, okay, and noting here that argument of z is modulus of z. Modulus of z is 1 by 2, correct? This is required, and this is modulus of 2 is w is 2. Now coming to this one, argument of z minus argument of w is equal to pi by 2. Now from here we can understand it, we can interpret it very interesting way. See, by applying the argument property I can write it argument of z by w, that is equal to pi by 2, correct? I can write it argument of z minus 0 by w minus 0, that is pi by 2. This is your final vector. Z minus 0 is final vector, okay, and w minus 0 is your initial vector, correct? That means it is something like that. This is final vector, this is w minus 0, so w is definitely lying in the fourth quadrant, correct? And then come to the z minus 0, this is 0 na, so z minus 0 may be here, like that, correct? Either this is or this one, that we have to decide. Okay, fine, that we can decide. How? The angle between them is pi by 2, so this angle is, you know that, 60 degree, okay, minus 60 degree, and the angle between z and w is pi by 2 means 90 degree, so therefore this z must lie in this quadrant only. Got it? So therefore the angle between them is 90 degree, and modulus of w is 2. This is 1 by 2. You have to find out the area by this O, Z and W. So the area is half into 2 into half, and that is equal to half. So this concept we have used. But you can also use the concept of rotation. We have used first the properties of argument. Argument of z minus argument of w can be written as argument of z by w by the properties of argument. But z by w can be written as z minus 0 by w minus 0. That is interesting concept, that is rotation of complex number, or you know that the how to find out the angle between the two vectors, okay. That is, this is final vector, this is initial vector. Z is can be written as z minus 0, w can be written as w minus 0, so therefore this is w is lying in fourth quadrant. The angle between these is 90 degree, and the argument of w is 60 degree, minus 60 degree of course, okay, then 60 degree and then 90 degree, therefore that must lie in the first quadrant. That interpretation, are you understanding? That is important. So therefore this one. But I can use the second concept also. What is that second concept? The rotation. Similar way, rotation of complex number. See how the rotation of complex number says. See, you are having, this is say w, and making the angle theta with the positive direction of x-axis. So therefore w can be written as modulus of w into e to power I theta. That is the concept. Now I am rotating this w by the angle theta. So we get z. Z can be modulus of z can be equal to the modulus of w, or after rotating w can be stressed, w can be compressed, so that the modulus of z can be increased or decreased or remain same if only rotated. So this concept is a rotation of complex number. We have rotated anti-clockwise, so therefore here argument of z is theta 1. This is argument of theta 1, correct, and this is theta. So argument of this is theta plus theta 1, where theta 1 is the argument of w, and w is rotated through the angle theta anti-clockwise to get z. After stretching w to get z, rotation and stretching, or rotation and compressing, or only simply rotation. But the argument is theta plus theta 1. That shows that w being rotated by theta degree anti-clockwise, so that the argument of z becomes theta plus theta 1. This is the concept of rotation of complex number. Now this concept we can apply over here. Here we can write down, look at here. what is given? Argument of z minus argument of w is equal to pi by 2. So this can be written as argument of z is pi by 2 plus argument of w, theta plus theta 1, theta plus theta 1. That means this w is being rotated anti-clockwise through 90 degree. So this is w in fourth quadrant. So therefore 90 degree it is rotated. So angle between z and w is 90 degree. So therefore the area is half into modulus of w modulus of z. So these two concepts, the rotation of complex number and this the locus, we know that the angle between the same similar way, but the way we are talking is slightly different. Otherwise the same thing. So this interpretation is very interesting. I have used first the properties of argument, then I have used the concept of final vector and initial vector and angle between them, the rotation concept. Basically the rotation theorem says like that, if w is rotated, the argument of w is theta 1, anti-clockwise through theta, the argument of z is theta plus theta 1. So argument of z is theta plus theta 1. So therefore w is being rotated to get theta by pi by 2 degree into anti-clockwise direction. That is, similarly you can say that the angle between z and w is 90 degree. The angle between z and w is 90 degree. The angle between z and w is theta. The angle between z and w is theta. Got it?